Hello and welcome everyone. In this end-to-end tutorial, I'm going to demonstrate the most practical usage of vector search on Google Cloud. We'll be reading the input data from a CSV file, creating embeddings out of it, and ingesting it into a vector search, which is a managed vector database service on Google Cloud. Now, ingesting into vector search means creating an index and deploying it to an endpoint, unlike conventional databases where you just write the data into them. Once ingested, we'll run the inference against this endpoint to fetch the results. Now, the input dataset that we will use is a CSV file containing synthesized data of job applicants. It has the name, the total experience, designation, and an overview of their skill set and projects. So that's the input dataset. Now, the idea is quite simple, but if you expand on it as per your requirements and use cases, it can be extremely powerful. Imagine a recruitment firm which receives tons of CVs. So, the idea here is to store all of this data into a vector data store, which in this case is Google's vector search, and then running a similarity search to get the most relevant results. So, for example, you can have an input prompt which says, I'm looking for data engineers with experience on Spark. This input will be queried against the vector database, and the results will be the most relevant profiles that match this input prompt. Now, for the tech stack, we'll be using Vertex AI with Python SDK, and the code execution will happen on a Jupyter notebook inside Vertex AI Workbench. We'll be using Google's Vector Search, which is a managed service on Google Cloud. And Vector Search, since Vector Search is part of Vertex AI ecosystem, we'll be creating the vector indexes and the endpoints inside Vertex AI using the Vertex SDK for Python. A couple of important points before we jump into the coding bit. By the end of this video, you must make sure that you've deleted all your services that you've created to ensure you don't incur any additional costs. And if you only perform the activities that I'm demonstrating in this tutorial, then you'd spend $2 to $5 at the most. So a trial account or a Google GCP trial account is good enough for this tutorial. Let's begin by creating a workbench on Vertex AI on Google Cloud. Now, Workbench is nothing but an instance of Jupyter Notebook running on virtual machines inside GCP. And it can come in extremely handy, especially if you're doing some sort of POC of some framework or interactive development using the Vertex AI SDKs with Python. So, to create a workbench, go to your search bar and type Vertex AI. And once you land on this page, just select Workbench from the left navigation. Now, let's click on Create New. And we got to give our workbench a name. So, I'm going to call this GenAI I'm going to leave the region and the zone as is. For the operating system, I'm selecting Ubuntu 20.04 and the environment, which is TensorFlow selected by default, I'm going to change that to Python 3. And you select TensorFlow only if you're developing something which requires the TensorFlow framework. Scroll further down. Now let's click on Advanced option. All right, now let's click on the machine type. And here I'm going to select the smallest machine type available, which is E2 standard 2, which comes with 8 gigs of memory with 2 virtual core CPUs. Let's scroll further down and enable the idle shutdown. This is quite important, especially if you forget to shut down your workbench and you want to make sure that you do not incur any additional costs. And I'm going to set the timeout to 30 minutes, which basically means if my workbench is idle for 30 minutes or above, it's going to automatically stop. It'll not be deleted. You can restart it, of course, after 30 minutes, but it's extremely important. So now let's click on continue, scroll down, and let's click on create. Okay, so you can see the workbench is starting to get created, and it's going to take a couple of minutes before you can start using the workbench for development. All right, let's get started with the code development. Now, once you have your workbench up and running, you can click on Open Jupyter Lab, which will open up a new Jupyter kernel. And once you're on this page, just click on this little upload icon and then upload the IPython notebook, which is job applicants, and also the CSV file, which is talent acquisition profiles.csv, because this is going to be our input data set. So the first code block pretty much installs the Google Cloud AI platform and cloud storage. I've already executed this entire notebook, so I'm not going to be doing it. This is just a walkthrough. So uncomment this line and execute this cell. And once you're done, comment it out, go to kernel and click on restart kernel. So we begin by importing the necessary libraries, which is pandas, storage AI platform, text embedding model, Vertex AI TQDM time, and these are my variables: project ID, location, bucket name, CSV file. Make sure to create a bucket or use an existing one if you already have a bucket. Also, make sure to change the values of these variables. We then initialize Vertex AI and read the CSV into a pandas data frame, which is quite simple. So if I do a df.head, you will see it has 5 columns written or read into a data frame. Next, we create a new column called combined underscore details. Now, this column is nothing but a concatenation of all of these existing columns. And the reason why I do this is because I want to create embeddings out of the combined columns because I want to capture all the details. Now, if you want to, you can only select a combination of 2 or 3 of these columns, or maybe even a single column, which is overview, maybe. Let's say, totally up to you. So we create a new column, combined details, by using a lambda function, which pretty much concatenates everything. And then I initialize my model by invoking text embedding gecko version 001. Now, if I do a df.head here, you will see the new column created, which is nothing but combination of all of this. Next, we define a function called getEmbeddings wrapper, which accepts the input text and the batch size is set to 5 by default. All this function does is accepts the input text and returns the embeddings. That's pretty much it. So next, I use the combined details, I convert it to a list, and I pass it to the getEmbeddings wrapper function, which is right here. Now, the result of this is going to be an embeddings, right, which is nothing but a vector, which is stored in a new column called embedding inside the same data frame. So if I run this, it's going to take a few seconds because we only have like 55 rows or less than 55 rows in the CSV file. All right, now let me do a df.head again. You can see all of these columns, most importantly embeddings, which is the vector form of combine underscore details column. The next step is to create a JSON L file, and I'm using all of the columns from the data frame except combine underscore details in order to create this JSON L file, because combine underscore details is pretty much useless at this point. And as soon as you run this code block, you will see a file candidates.json created in your current working directory. Now this JSON file looks something like this. So it has all the keys, which is nothing but the column names and the respective embedding for each row. Once the JSON file is created, you just copy it to your GCS bucket. I'm copying it to the root of my bucket. That's pretty much what the last command does using gsutil. So if you run that, you should see a JSON file sitting in your bucket. And we need to create this JSON file because this is going to be our input data, which will be fed to our vector search or vector search data store, however you might want to call it. All right, next comes the most crucial part. So once you've created the JSON file, copied it to a GCS bucket, we then create an index. Now, typically when you use vector search on Google Cloud, there are 3 steps involved. The first step is to create an index. The second step is to create an endpoint. And the last step, or the third step, is to deploy this index to the endpoint. The first and the last step are time consuming, meaning each one of them take at least 35 to 45 minutes. All right. So go ahead and run this code block, which invokes the create tree AH index, which pretty much creates an index. It has a display name, the contents delta URI, which is where your JSON file is residing. Dimensions is set to 768 because we're dealing with textual data. Approximate neighbors count 20. 20 is the number of similar items that will be returned and similar to the input that we provide at a later point. Now you can change this to 5, 10, 15, doesn't really matter. Distance measure type is dot product distance. And that's pretty much it. Running this code block is going to start the execution of your index creation. So you can go back to your Vertex AI, click on vector search, and you should see your index which has started to get created. All right, in my case the status is set to ready because I've already executed the entire notebook, but in your case, like I said, it's going to take at least 40 to 45 minutes. But you can grab the idea of it in case you end up losing connection. Let's say you run this code block and then you come back after 2 hours. Chances are you've lost the connection, so you need not create the index again. What you can do is comment this part out and uncomment the last 2 lines. All right, and just get the ID from here and paste it here. So you can start from this point. You need not create the index again, which is going to take another 40 to 45 minutes. So just something to keep in mind. All right, so once your indexing is done, the next step is to create an endpoint, which takes absolutely no time. So just go ahead and run this code block. Once you're done with that, we run the last step, which is deploy underscore index. Like I said, it's going to take at least 40 to 45 minutes. So run this code block. And once you're done with this part successfully, you can go back, click on Vertex search, click on the index, scroll down under deployed indexes. You should see your index along with the endpoint. And most importantly, you should see the status set to ready. Like I said, you got to give it at least 40 to 45 minutes and then come back and check if the status has changed. Now, status set to ready basically means your endpoint is ready to be queried now. So we can go back to our Jupyter notebook and now we can try out different prompts. So I'm saying we're looking for a data analyst with experience in creating dashboards and writing SQL queries. And the expectation is that the vector store or vector search will return the relevant candidates only. So we convert this prompt into embeddings so that embeddings can be compared against the embeddings which is already residing in my vector store, and then return 5 candidates from the result. So if we run this code block, we get the response. It's set to 100%. I'm not printing it yet. Also keep in mind, you can try out different prompts and evaluate the results to see how it's performing in terms of similarity. All right, in order to print the the return response, I'm using NumPy and I'm using an enumerate function in Python. This is pure and simple Python. I'm going to print the name of the candidate, the overview, the total experience, which match this specific user prompt. So let me run this, and there you have it. I mean, I can decorate it better, but you can see the score as well. This is the similarity score, 0.76 or 76% being the highest, which is of the candidate Olivia, uh, who has assisted in data cleanup, preliminary analysis, created visual reports, and you can see this overview sort of matches what we're looking for. What we're looking for is a data analyst with experience in creating dashboards and writing SQL queries. So that was it. You can try out different prompts and see how your vector search is performing in terms of returning similar or relevant matches. So we've created embeddings, stored them into vector search, and our inference is running as expected. Now comes the last part, which is running inference against the endpoint, which we have deployed earlier, as a standalone application. For this part, I'm just going to show you the code, and it's quite simple to deploy it if you have experience on Google Cloud. You can probably deploy it on Cloud Run as a Docker container. You can even deploy it on App Engine or Compute Engine. Totally depends on you. Now, in order to deploy the standalone application, you just need AI platform. You need the text embedding model, QTDM time, the project ID location, which is a must, obviously. You initialize the AI platform, and then you instantiate your model object. You must also get this function, get embeddings wrapper. And the reason why we need the embeddings part here is because the input or the user prompt needs to be converted into a vector as well, right? So that it can be compared against the embeddings which are stored in the vector store. So that's why you need this. So let me run this. And next comes the most important part in terms of inference. You need to invoke the same endpoint that you had created earlier. So I've created a variable called candidates underscore endpoint. You can call it whatever you want. But the most important part is this pattern. So the path to your endpoint follows this pattern. It's projects followed by your project ID, followed by locations. US Central 1 is the location that I'm using, followed by index endpoints, followed by the ID of your deployed endpoint, which you can get if you go to Vertex search, click on the index, click on the endpoint, and this is your ID, your endpoint ID. And this is the one that you need to grab and use it here. All right. So you define your endpoint by pointing it to the deployed endpoint, and then the rest is pretty much the same. So this is your user prompt, which is converted into embeddings using the get embeddings wrapper function. This is your deployed index ID, which is the same as the one here. And then you invoke find neighbors function. That's pretty much it. You can change the number of neighbors that you want as a result. So if you run this, and then finally you print out the response. That's pretty much it. Now, if you look at the response, you only get the ID. Now, this is the unique identifier in the pandas data frame, right? Now, using this ID, if you want any other attributes like the name, the experience, the designation, overview, and whatnot, you must do a lookup. So the idea is that you must store the original data set in a NoSQL database. You can probably store it in a MySQL database. The underlying data store or database totally depends on the response time that is expected from this entire application. So that was that for this tutorial. Let me know in the comment section if you have any questions, and do not forget to subscribe for more hands-on tutorials. Thanks a lot for watching.